Okay, Lamai, we have discussed up to here, and now I'm going to discuss about reactions of metals with solutions of other metallic salts. Let us conduct activity 16.7 in order to explore how metals react with the solutions of salts of metals. Copper sulfate. This is a salt of metal copper. Solution of other metallic salts. The topic is solution of other metallic salts. So, uh, here the metal is copper and the salt is copper sulfate. An aqueous solution of copper sulfate can be prepared by dissolving this salt in water. That means dissolving this copper sulfate in water. So by dissolving copper sulfate in water, metal copper, we can make an aqueous solution of copper sulfate by dissolving this salt in water. Let us use the reaction of metal zinc with a copper sulfate solution in this regard. Requirements: a beaker, an aqueous solution of copper sulfate, clean zinc metal. A beaker and aqueous solution of copper sulfate, clean zinc metal. Add copper sulfate solution to the beaker. Add a zinc granule to it. Record the observation. Okay. Copper sulfate solution is blue in color. It can be observed that the intensity of the blue color of the solution diminishes with the formation of brown powder. Here the following single displacement reaction occurs. Now you know about the types of reactions. So copper sulfate into zinc, it becomes zinc sulfate and the copper remains. So that's why we get a brown powder, formation of a brown powder. Blue color of the solution where the copper sulfate was there, it diminishes. Why? Because it converts into zinc sulfate. No reaction occurs when copper metal is added to the zinc sulfate solution. No reaction occurs when copper metal is added to the zinc sulfate solution. In the other way around, if we add zinc sulfate into copper, no change is observed. Okay. Only a metal which is more reactive can displace another metal from an aqueous solution of it. More reactive නම් විතරයි එතන යව replace කරන්න පුළුවන් වෙන්නේ, displace කරන්න පුළුවන් වෙන්නේ. Only a metal which is more reactive can displace another metal from an aqueous solution of it. Accordingly, zinc is more reactive than copper. So it can displace copper from a copper sulfate solution. But copper cannot displace zinc from a zinc sulfate solution. Thus, okay, now you see that copper can be displaced by zinc, but zinc cannot be displaced by copper. That means zinc made the bond and it can't be broken. It is very strong. Oh no, it can't be broke. Copper get remain. Even though we put copper into zinc sulfate solution, it doesn't give any change. So accordingly, zinc is more reactive. That means zinc is more reactive. That's why it react with copper sulfate and make the zinc sulfate, and because of its reactivity, it does not give its sulfate part to copper. So it can displace copper from copper sulfate solution, but copper cannot displace zinc from a zinc sulfate solution. Okay, I'm repeating this thing in order to make sure whether you get it. Thus, of zinc and copper, it can be inferred that zinc is a more reactive metal. Is that true? Yeah. That's why it makes this compound and it don't give that sulfate part to copper after that all. Ready? So let's see whether zinc or copper is very Reactive, yeah. Zinc is here, copper is below. So what is very reactive? What's reaction rate is high? It's zinc. What is more reactive? It's zinc. Okay. Copper is less reactive compared to the zinc. Now we come to this activity series. The reactivity shown by metals with oxygen, water and dilute acid is different from one another. You observe it, no? The activity series is built up on the basis of those observations as well as other data. The series obtained by the arrangement of metals in the descending order of their reactivity is referred to as activity series. So here the descending order means the more reactive ones are in the above and less reactive ones are in the below. As in the case of this zinc and copper we previously talked. Yeah, that's true. Now uses of the activity series. Activity series is useful to identify the precautions to be taken. Why we need this activity series? That is what we are going to learn here. Okay. So uses of activity series. Activity series is useful to identify the precautions to be taken when storing metals. When storing metals, we need to do some precautions. So in some metals, not for all, okay? Like this, the metals with high reactivity such as sodium, yeah, it's in the above part, potassium, yeah, it's also in the above part, and calcium, yeah, the first three, sodium, potassium, sodium, calcium, should be stored in liquids such as kerosene and paraffin. Because of their high reactivity with air, they react with components in air if they are kept exposed to air. So we have to keep them in a liquid. It could be kerosene or liquid paraffin. Otherwise, because of the high reactivity of these three metals, they are going to react with air and make some another substances rather than their own form. Okay. Next use. Activity series is useful to find methods that prevents corrosion of metals, keeping iron in contact with metals like zinc and magnesium that are more reactive than iron to prevent rusting of iron is example. Okay, I'm going to describe you this thing. So this activity series is used for iron rusting to avoid the iron rusting. What is that? See where the iron is located. Yeah, it is in here. Okay, so the iron is located in here. Okay, so what is the thing happen when iron get rusted? What is the thing it happen to the iron when it get rusted? So it react with oxygen in the air and make that compound. Okay, so when we think of another metal which is located above the iron as potassium, sodium, calcium, magnesium, aluminum, zinc, mainly we can't keep them because they are very high, their reactivity is very high, so we go with magnesium, aluminum or zinc, basically zinc. If we contact iron with zinc, what happen? Zinc react with the air and it make that compound and it avoid ferrous to become that compound like this. Here see, with zinc sulfate and copper, this zinc doesn't allow copper to become copper sulfate. It kept copper in its original metallic form, no? It keeps copper as copper. It doesn't leave copper to become copper sulfate. As same as that, if we kept ferrous with contact with zinc, uh, it doesn't allow ferrous to become the compound react with oxygen because zinc react at first. Okay, so activity series is useful to find methods that prevent corrosion of metals. Keeping iron in contact with metals like zinc, what happened? And magnesium, okay, both were there, and aluminum also were there, but they take zinc and magnesium that are more reactive than iron to prevent rusting of iron is an example. Next one, activity series helps select metals to make electrochemical cells. Electrochemical cells, I think you remember we learned them in grade 9, but we didn't come to that part. We didn't come to that part in all of our syllabus. So for the electrochemical cells, this activity series is very useful in order to find what is the anodic reaction, cathodic reaction. Then activity series can be used to decide on the methods suitable for extracting metals. Metal extraction involves the separation of metal from nature ore which contains that metal. How the metals occur differs according to their reactivity. So think like we are going to extract copper here as an example. If you put zinc, what happened? You get the pure copper. It can't be changed. We can obtain that pure copper. See, like if there's a kind of with zinc, yeah. If you need to extract gold, you can put any above one. Basically, we put mercury to extract gold, the pure gold, because to mercury the pure gold come like that. You can use any other metal lies in the above part of the activity series, the metals which are in the upper level of the activity series than the considerable metal we consider. Think like if we need to extract copper, we could go with any metal in the above part. If we need to extract lead, we could go with this above part, but we can't go with below ones because when we consider two metals in this activity series, අපි මේකේ metal දෙකක් consider කරොත් උඩ ඉන්න කෙනා තමයි reactivity එක වැඩිම එක්කිනා, යට ඉන්න කෙනා එයාගේ own form එකම තියෙනවා, උඩ ඉන්න කෙනා තමයි compound හදන්න කැඩිලා යන්නේ. As an example, zinc sulfate with copper. So ඒ වගේ අපිට copper extract කරන්න ඕනොත් what we can do is we could use this activity series and find any metal above than the copper, then we can use it. That is a use of the activity series. Metal extraction involves the separation of metal from natural ore වල තියෙන්නේ. ඒ වලින් තමයි separate කරලා ගන්න. ඊළඟ use එක reactivity metals such as sodium and potassium cannot be seen as native metals in the natural environment. Yeah, they can't be exist as native metals. They are found as very stable ionic compound in the environment. In order to extract, they exist as compound. No? In order to extract them, electrolysis, a robust method of extracting metals, has been used. These metals are extracted by the electrolysis of their fused. Fused means Like when we consider about copper sulfate solution, we discussed that we can make a solution of a metal, yeah, by adding water to in it, no? So here we are not going to add water and make the solution. What we are going to do is we can mold, we can melt. Think like it's sodium chloride. ලුණු කැර ටිකක් කියලා හිතන්නකො අපි ලුණු කැර ටිකක් දාලා ඒකට වතුර දැම්මොත් ඒක sodium chloride aqueous solution එක. sodium chloride aqueous solution එක. හැබැයි අපි ලුණු ටිකක් අරගෙන ඒක උණු කරලා දිය කරොත් ඒක මොකද? ඒක molten sodium chloride. එතන වතුර බිඳුවක්වත් නැහැ. ලුණුම තමයි අපි උණු කරලා ගත්තේ. එතන අපි සාමාන්‍යයෙන් NaCl කියලා ලිව්වට පස්සේ මොකද ඇති NaCl කියලා ලිව්වට පස්සේ අන්න මෙහෙම අපි ලිව්වොත් NaCl කියලා අපිට මෙහෙම ඉන්ද්‍රගසාල aqueous කියලා දානවා අපි aqueous solution එකක් නා හරිද හැබැයි අපි හිතමු මෙයා අපි මේ උණු කළ දිය කළගත්ත එකක් කියලා. ඒතකොට අපි දාන්නේ මෙහෙම liquid කියලා. liquid. හරිද? sodium chloride aqueous එකයි sodium chloride liquid එකයි. හරිද? fused molten කියන්නේ මේ liquid එක. මේ aqueous solution එක. The metals of, okay, this is to be discussed in grade 11, so don't get it, so don't be confused with it. If you didn't get it, don't be afraid, okay? I think you got up to this part, and if you didn't get this part, just leave it. The metals of moderate reactivity such as iron, tin, zinc and lead are extracted by reducing their compounds by other elements or compounds. The same thing which we discuss in here. We can use the moderate reactivity ones: ferrous, zinc, tin, lead. Ferrous, zinc, tin, lead are these four. Moderate reactive for these four. See, zinc, ferrous, tin, lead, these four. Yeah, iron, tin, zinc, lead are extracted by reducing their compounds by other element compounds. The metals of that means from the, yeah, above, if we use any compound above them, we can obtain the metal version, that means the pure version of this one. The metals of moderate reactivity, yeah, we discussed. The metals of low reactivity such as silver, gold and platinum occur in nature as the native metals. Why? They are not reactive. They are not very reactive. So they exist as a native. They do not need to be make a compound with other ones. So they stay as native metals mixed with other compounds. They are extracted by the physical methods used to separate the mixtures. They mixed with other compound. They didn't make any compound. They just stay as a native. ඒ කියන්නේ ඒගොල්ලෝ කෙලින්ම silver, gold, platinum විදිහටම ඉන්නේ. කවුරු එකක් mix වෙලා silver sulfate එහෙම නැහැ කොහෙවත්. හරිද? එයාලා native විදිහට නෑ. එයාලගේ reactivity එක අඩුයිනේ. එයාලා පල්ලෙහාම ඉන්නෑනේ. ඒතර මේ silver, platinum අවුරම් නැත්නම් gold. එතකොට ඒගොල්ලෝ පල්ලෙහාම ඉන්නෑ නිසා එයාලා කායකවත් react කරන්නේ නැහැ. එයාලා just native metal විදිහටම ඉන්නවා. හරිද? ඒතර native metal විදිහටම ඉන්නකොට හැබැයි වෙන කම්පවුන්ඩ්ස් එක නම් මික්ස් වෙලා ඉන්න පුළුවන්. ඒ කියන්නේ පස් එක්ක යකඩ එක්ක මික්ස් වෙලා ඉන්න පුළුවන්. හැබැයි මෙයාලා කම්පවුන්ඩ්ස් හදන්න ඇතට ෆිසිකල් මෙතඩ්ස් පාවිච්චි කරලා තමයි separate කරන්නේ. Hence, strong extraction methods such as electrolysis are used to extract metals at the top of the activity series. Activity series එකේ top ඉන්න කට්ටියව extract කරන්න අපිට ඕන වුණා. Strong extraction methods More simple physical methods are used to extract metal at the bottom of the activity series. Physical methods පාවිච්චි කරලා bottom තියෙන ඒවා ගන්න පුළුවන් කියලා කියන්නේ. දැන් අපි යනවා extraction of iron. මම iron ඉන්නේ කොහෙද? එයා ඉන්නේ මේ moderate හරිය. මේ හරිය high reactivity, මේ හරිය moderate reactivity, මේ හරිය low reactivity. හරිද? එතකොට moderate එකකිනේ තමයි iron. Extraction of iron ගැන අපි කියලා දෙනවා ඉස්සරහට. ඊට පස්සේ extraction of gold ගැන කියලා දෙනවා. gold කියනකොට පල්ලෙහා ඉන්න කෙනෙක්. මේ දෙක තමයි තියෙන්නේ. මොඩරේට් එක්කිනෙකුයි මොඩරේට් එක්කිනා ඉතින් හයිඩ්‍රජන්ට උඩනේ මේ අපි හයිඩ්‍රජන් එක මාක් එකක් විදිහට දා ගන්නවා. හරිද? ඇක්ටිවිටි සීරීස් එකේ හයිඩ්‍රජන් කියන තැන එක මාක් එකක් විදිහට දාගෙන එතනින් උඩ ටික ටිකක් රියැක්ටිව් එතනින් පහළට ටික රියැක්ටිවිටි එක අඩුයි කියලා ජස්ට් කන්සිඩර් කරනවා. හරිද? එතකොට මේ ඒකයි යකඩ එක උදාහරණයකට අයන් එක උදාහරණයකටයි එක්ස්ට්‍රැක්ෂන් ඔෆ් අයන් මේක ගොඩක් කෙමිකල් කියන්නේ ගොඩක් රියක්ෂන්ස් ඉක්වේෂන්ස් ගොඩකින් සිද්ධ වෙනවා කියලා කියන්නේ සහ එක්ස්ට්‍රැක්ෂන් ඔෆ් ගෝල්ඩ් හරිම ලේසියෙන් ෆිසිකල් විදිහට කරනවා කියලා කියන්නේ. මම ඒ දෙක ඊට පස්සේ ඩිස්කස් කරන්නම්. ඊට ගෑසස් ගැන තියෙනවා. ගෑසස් වලින් පස්සේ අපේ ලෙසන් එක ඉවර වෙනවා. හරිද? මම ගෑසස් එකයි අන්ස්ට්‍රක්ෂන් එකයි පස්සේ කරන්නම්. I'm going to stop here right now. Okay. Thank you.